So I'm going to be presenting generics in TypeScript. This will be pretty basic, covering generics up through type constraints. I won't touch on mapped or conditional types or anything more complicated than that. I'm going to be using a project for this presentation. You don't need to view the project, but if I go fast or you want to look at something more closely, you could follow either of these links to get to the GitHub repository, or after the talk if you're interested in looking. By the way, my name is Tyler Leonhardt. I'm a former Microsoft employee. Currently, I'm starting my own startup. So the motivation for generics is really to reuse code, and it's reuse in a similar way to how you can use a function on multiple values. The difference with generics is that you'd be using the same function on multiple types. Generics also work on classes in TypeScript, not just functions. Out of the box, you get the array type in TypeScript, and it's really probably the most prolific generic type. It has a special syntax, which is the first syntax you see with the brackets, but it can be represented with this chevron syntax, the second one. I call these things around the word number chevrons, and that's how all of the other, for the most part, generic types are going to be represented in TypeScript. And you'll see that syntax after a generic type identifying a variable, and you'll also see it with its own kind of variable type. Usually you'll see the letter T in the definition. There'll be more on that later. So the syntax, that chevron with the number in it, tells TypeScript what the array contains. Essentially, the TypeScript definition says this thing is a list, and that's what the word array would be. And then when you put the number after, you're saying it's a list of numbers. If you add a generic parameter, or if we replace this number one up here, we can instead store strings in our array. But neither one of these would work with the other. In other words, the strings wouldn't work in the number array, and the numbers wouldn't work in the string array. All right, so we're going to make some of our own generic types. Both functions and objects can be generic, and we'll do a little bit of both. And we're going to use generics to improve a game played by mages. So the mages in this game can use potions, which I've got right here, or spells. I've got a health potion and I've got a magic potion if anybody wants to try them afterwards. Potions are single use, so you pick one up, you use it, and it's gone. And the spells can be used multiple times. And also, potions and spells are stored in different inventories. So the inventories are going to be the things that are generic. The mages look like this. Can everybody see that? Is that big enough, basically? Okay. I actually frantically resized all of my font, like as the last presentation was going on. So these are what our mages are going to look like. They've just got spells and potions inside of them, and they're stored in this other class called an item collection. And then the false and the true we're passing in here tell us whether it's consumable or not. So potions are consumable, you drink it and it's gone, and spells are not. They last forever. So that's what the mage looks like. The item collection itself looks like this. So it's got that is consumable I talked about earlier, and then it's got the list of items. And right now, the list of items is any. So anything can be stored in the item collection.
We're done. Most generic.
Right. When you pick up an item, it just gets pushed into that list. And when you use an item, it'll just choose a random one from your list of potions or spelled. And then if you had any, it will call a callback on the item. So for example, if you call this with 0 potions, nothing would happen. So the way the code looks to use these mages then is like this. You just declare a new mage. He's going to be able to pick up spells and pick up potions. And then you've got this slightly ugly callback syntax you have to use the potion. Now, the problem with this is that because we define the items as any, we can store spells in the potions inventory, or we could store potions in the spells inventory. The inventories don't really have any knowledge about the things that they're storing. Without generics, there is a way to fix this problem, and it looks like this. This is the biggest slide. You don't really have to read this code. All it is the previous slide, so this one, and we took that word any, and we hard-coded spell or potion into it. And essentially, this is what you may do in a programming language if it didn't have generics. Just anytime somebody comes along and wants a new item in your game, you're like, all right, I'm going to get that code out, paste it, Control-C, and then paste another word all over it until it starts storing potions or whatever it is that the person asking for wanted. Again, this is the previous version, and the problem here is that we duplicated a lot of code. So there's got to be a better way of doing this, and that's where generics come in. So that same syntax we used with the arrays earlier when we were doing the variable declaration, we can put in the declaration of a class, we could put it on its first line, and it'll follow the class or the interface or even the function. And the thing between the chevrons is called a type parameter. You can separate them by commas if you had more than one. We only have one here. And basically what we did is we just took all the code that said any and we replaced it with that type parameter. So again, the old code and the new code. And you can see just the bits that changed are that T. And if you had a bunch of code in your code base that had any's all over it, it is reasonable. You wouldn't be able to get all of your code, but you might be able to get a significant amount of it just by changing any's out with generic parameters in functions and classes where all the things that are any are all the same type. So in other words, all these T's here in this array, everything, once you specify that T, it's all going to have to be the same type. So now we can use these generics. After the word item collection, between those chevrons, we would say spell or potion. So now we've got two separate inventories that can only store spells or potions. And this code right here, this would no longer work. The previous code would actually compile. This one will not. There's an additional problem here, though. You're designing your game, you're adding more and more inventories, you're working with a bunch of other developers, and then somebody adds numbers as an item. And you're looking at it and you're like, well, that doesn't have anything to do with our game about magic and spells and potions. Who added this? How was it even possible? So the problem with our original implementation is that the item collections can contain anything. And we still want to be a little bit more specific than that. We know that the potions and the spells are going to be used in a certain way. They're either going to damage your opponent or modify your own stats, maybe raise your own HP. So maybe because we know that functionality is the same, we can encapsulate it and reuse it and prevent this other sort of code. Is there anything we can do? So we can add a generic constraint. A generic constraint is this bit in the chevrons, extends, and then some type or interface. And what this is going to say is that whatever type we use with our generic in the future is going to have to implement this interface. Otherwise, we're going to get an error. In other words, because spell and potion implement our interface, they'll work, but number will not. This will no longer be possible, or any other type that's not going to work in our little game. Additionally, I mentioned at the beginning of this talk that we had to use spells and potions through a callback. That's because we knew they were T's, but we didn't know exactly what type of T's they were. Now that we know they're items, and items have a use method on them, we can make this code a little bit simpler too. So this is the old code where we're calling that callback on some t. We can now just say we're going to use it on a mage, whatever the spell or item is, and then we can call item.use. And again, item is going to be a t. We could call its use function because we know it extends the magic.I item. In other words, this becomes this. So that's it for generics and TypeScript. I do have the game working if you want to watch the mages fight.
Oh, yeah. Yes. Yeah.
All right, so they take about 30 seconds. There is a dark mage and a light mage. Does anybody want to vote on which one's going to win? Just shout out which one you think will win. Dark mage?
Evil people.
All right, here they go. So they're going to be using their spells and picking up potions. Light mage used fire. Dark mage used fire. Light mage picked up a power potion. You can see their health. It's the first number, so 7967. Light mage used a power potion. Light mage used fire. It's not looking good for the dark mage. Oh, dark mage lost. Anyways, that's generics and TypeScript. If you want to try some of the potions later, let me know. Let me know if you have any questions also.
How long have you been working on this book, the Dark Mage, Light Mage stuff?
It was probably too long. I actually had vacation last week, and I started it 2 weeks ago. Yeah. So I like literally just did this for the presentation. And I actually had a whole separate example, and I was like, I can't use this. It's not like relevant or fun. So then I was like, well, what's going to work? And then I was like trying to figure out how to get this example to actually work with the topic. And I spent like so much time like trying to figure out like, oh, should it be spells and potions or something else? And how do I set the inventories up so I can actually have like errors while I present it? I previously like did some sort of logging thing. That was my original example, but I was like, man, everybody writes a logging thing. Like I got to do something different. So yeah, actually, if you downloaded the GitHub package, if you were interested in using this, it's kind of nice because the spells and potions are just in the spells and potions files, and literally all they are is a bunch of like user.magic -3, user.speed +1, health minus whatever. So I just define like a whole big list of potions, and I'm just like magic +25 for the magic potion, defense +3 for the defense potion. If you wanted to use this for some other like example or something.
Good job. Cool, thank you.